Welcome back. I got a phone call and had some other things to do, so it's been a while since the last session. Anyhow, when I left off, we were going to work on these shelves, and specifically we wanted to make the opposite side. However, I think I'm going to work on it in a slightly different order. So we have these two, and I think I will make a new union containing them. So we use the part workbench for that. And we see that the union contains the mirror of the shelf and the shelf template. This way they can be handled as a group. We will be putting it in here, and in fact we no longer need these two. They are but things are a little bit confused if I do it that way, so we just remove these from the fusion, and note that we now only have one object inside the fusion. That's perfectly possible because a fusion only merges all of the objects that are put inside it, even if the operation looks like it requires two objects. So now we have these two, and you can now see the relation that the mirror is in fact based on the original, and we can union those two in order to have both sides. But I wanted to create the overhang cut, and I wanted to create the mirroring to put it in place inside of the container, because the container is going to be somewhere around here. I don't see the origin at the moment, but it's there somewhere. And the overhang cut shouldn't actually affect this bottom shelf, so we can include the overhang cut in that bottom shelf with the way I have designed it this time. So we start working on the shelf template itself. We want to cut away what would be overhang. So this is the appropriate perspective for, well, the first idea of how that is done. We need to create a new plane, actually, in order to make this cut. But the plane is at a rather odd angle, because this point should be in it, this point should be in it, and it should also hit this point. So in fact that might be the easiest way to describe it. So if I select these points and create a plane, a new datum plane, there. This should be precisely the overhang cut that we need. And if so, then the resulting slice will remove that. So the plane itself doesn't create two sides. Well, it creates a frame of reference. And we now need to add something to perform the geometric cut. the fusion is actually confused because there's only one part inside it. But we will put the shelf back inside in a little while. What I want to do right now is to slice away this overhang section, and we can do that either by just creating a big box or something to cut off there, but I'm wondering if it is possible to use the plane itself to perform the cut. I don't know. There's a draft on a face, there's pocket with a selected sketch. There's really nothing here. The simplest way I can draw it in this case is on this plane I create a sketch, and the sketch will contain something, doesn't really matter what, so I'll use the center point and something really large, and in order to have it constrained I will just set the radius here to, let's say, consequences container depth. That's big enough. Close, and use that to perform a cut. So that should be a pocket. This looks weird. Cancel that. I want this sketch and I want a pocket. Why does this look weird? I am not so sure. There is something wrong about this. Let's check. Not enough shape objects linked. Let's just remove this fusion itself by moving out its contents and deleting the fusion. Yes, the bottom will break if I put this back in. Well, I'll be reworking the bottom in a short while anyway. This cube I just want to delete this object there. This cube, I will name it underground. That's part we do not want in the final model. And the bottom is now intact, and we have this sketch here that I want to perform the cut with, and we should have this as our active object. There you go, that's the active body, and if I perform the cut, then it is confused. That is unsatisfying. I can see that the plane has the correct orientation, but the cut doesn't work. And let's just remove the mirror for now. Here. This object now looks okay. Let us perform the pocket operation. It does the wrong thing. Let us alter the sketch. Just change this radius to 5 millimeters and see what happens. I am a bit of a beginner at all this, but the idea is that this whole plane does coincide with this edge, and if I want to cut out one side of it. So if I perform a pocket operation here, then we get a hole in our piece. This hole actually looks wrong, but it is a hole where I want it essentially. I just want it on the other side, so we reverse it. And I want it to be bigger, and I want it to cover it all. So we set it through all. Now it goes all the way. So that functions correctly. And if I edit the sketch and change this constraint to be really large again, consequences container depth, just a relevant measure, then things break. So there is a problem. It does not work if this circle is too large. Does it work at any particular size? It would appear that the problem occurs well, basically at any size I can set here. No, problem goes away. Set it really big, and the cut looks fine now. What happens if I set the constraint the way I wanted to, so that it is relative? I just want this to be large. Container depth times 2. And it updates, and we have our datum plane, and now it looks okay. I don't really know why it had trouble before, but right now it seems to be working. It's annoying when you don't find the explanation for things. So this is definitely with the overhang cut. Whereas this pad would be the template without the overhang cut. And again, we want it on both sides, so now it's time to mirror it. And that, well, it's possible to use mirrored features in part design. In this case, I want these two shelf sides to be on either side. They will not intersect, and therefore it does not work as a part design body. Or I don't think it works as a part design body. So we're going back to the part tools and creating that mirror. So we mirrored the entire body, not just the pocket. And this way, also we will mirror it about the YZ plane. Okay, so we're back at having the bottom shelf, and this shelf can then be arrayed and so on. We want to handle these in pairs, so we select both of them and perform a union. This fusion is one shelf layer. And we can see how the bottom fits in. Actually, we need to make it visible. There we go. So we now have our overhang cuts, and we have a shelf, and it is time to make more than one shelf. This we do using the array operator. So there is the offset shapes, there is the thickness. Where is the array? Because I do believe this is either a part or a draft operation. Here we go. Under drafts we find create copies of a selected object along a selected path. That's almost right. I want this, a polar or rectangular array from a selected object. Now, it's going to the right. That is not the way I want it. In fact, I don't want any copies in X or Y. I want a copy in Z for the moment. And in distance and orientation of intervals in axis direction. Oh, that is a little bit confusing. But the basic thing is we want to duplicate it. We don't want to be twisting this. We are using an orthogonal, not a polar array. Although it is possible that a polar array will work pretty well. Let us first set the interval axis here. Let's set the Z to consequences.shelf height. And how many of these do we want? Let's make 3 to see what happens. This is not quite right, but it is interesting. Notice that these shelves are actually at relevant heights. But there are only 3 of them going around the full circle, and we have 3 set here. We also have this set, but basically the way the array operation works is it's either going to use the axis section if you use a polar array, or it's going to use the XYZ if you use an orthogonal array. In this case, I think that a polar array is actually quite applicable. But we're going to have to go back to our parameters and look at the number of shelves. So when we look at the number of shelves, so we set the number here to equal to parameters.shelves, and we set the angle to 180 degrees times the number of shelves. That is interesting. It's not right, but it's a start. So we change our formula. If 180 degrees is wrong, then we try 360 degrees. And what do you know? We have 1, 2, 3 shelves. Let us adjust the parameter. Something happens. Let's just make these windows all show, and we see this is not right. So we see it go around 1 full revolution to the top shelf. That's not the amount we want. We want it to go around 180 degrees per shelf. And so how do we do that? Now I've lost track of where that number is. There it is. In angle. So if this is what we got here, something's off here. If I tell it to go 180 degrees, in fact, let's discard that so we can just set the numbers ourselves. If I tell it to go 180 degrees, it will go 180 degrees to the top shelf. If I tell it to go 360, then the top shelf does not end up where the bottom shelf started. And that is interesting. So 180 degrees here. What happens if I set it to 90 degrees? It goes 90 degrees in total. There's something funny about this. 360 should put it back on the right side, but it doesn't. It's missing 90 degrees, so if I go 5 times 90 degree, then I get an odd angle. The top is in fact at 5 times 90 degrees, but it's showing 450 degrees here and 360 degrees here. This is not what I would call particularly predictable. However, halfway between those two, add 45 degrees. Nope, that's not halfway. Something is severely wrong about this. Well, we have a few options. I could just not bother with it, or I could figure it out. For now, I think I am going to leave this alone. I see the number of shelves I want, but I don't see them alternating sides the way I want them to. I really would have expected that the correct formula would be something like 180 degrees times the number of shelves, but that just doesn't produce the result I want. And I'm not sure why. It's something about the interpolation. It figures out the final position of the last one, and then it just goes around with as many instances as it needs. It doesn't go around in the direction I requested, and it doesn't go around as many times as I requested. It would make sense then if 180 degrees would do exactly what I want, but it doesn't, because this is just the final angle that it ends up at. It is not the angle of each step. So we are going back to our backup plan. I am using an orthogonal array, and this array has an interesting formula here. We are going to use the ceiling function, and we're going to use the parameters.shelves divided by 2. So this produces 2 instances. We're setting the interval to consequences shelf height. Now we see 2 shelves here. 2 shelves is about right, but there's a problem. They are too close together. They are in fact overlapping. So we change this to shelf heights times 2. That's a start. Now this shelf should disappear if I set the shelves to 2. It should still be there when I have it set to 3. But if I set it to 2, then it goes away. If I set it to 1, then well, I still have the original shelf because that's not part of the array. Back to 4 shelves. So this array is basically functional. And now I want to clone that array. Or actually I want to make what's a very similar array that is on the opposite side. So again, I select the shelf and I make an array. I'll call this the back shelves, and this new array will be the front shelves. Again, we see that there's a variety of settings. I am going to alter this to be consequences shelf height times 2, exactly as the other one. And I'm going to set the number like before. This time I will use the floor function. Consequences.shelves. No, this is in the parameters. Over 2. And we want to move this to the opposite side. So I'm going to turn it around 180 degrees. Not there. I'm going to actually turn the entire array object around 180 degrees. As you can see, it's now in the wrong position. And I'm going to raise it up with consequences.shelf height. There. So that's the appropriate height, but I need to move it closer to the right. And the question now is how far? Because we know we wanted to rotate it actually around an axis somewhere over here. That axis is halfway through the container. So we're going to move along the y-axis. And we're going to move by consequences container depth. And let's just try that. And that actually looks absolutely right. So we have our shelves, and if I use 3 shelves, the top one disappears, 2 shelves, 1 shelf, and we see the problem. And these shelves on the front side do not go away. So we alter our position. We put the array down here, and we change the formula for how many we want. The problem is here because 0 is not enough shape objects. So we set it back to the floor of parameters that shows plus 1. And I think that will be correct. So the 1 shelf we're counting right now is this shelf. if I set it to 2 shelves, we receive this shelf. 3 shelves, this shelf appears. Things are looking decent. And it's specifically this sort of change that we want a parametric CAD system for. Now, this shelf obviously should not exist, but that's not such a big problem. Just like we do with this bottom corner here, we can cut it away using the underground box. So we make sure the underground box is big enough. We just make it a bit higher, and that requires its placement. Actually, we can simplify this. We discard this, we set that to 0, and we rotate it about not the z-axis, but about, say, the x-axis by 180 degrees. No, the y-axis actually, just so that it's still below there. And I think because of that we no longer need this position either. Either that, or we need it to be yeah, the other way. Doesn't really matter. We need parameters dot length plus parameters dot margin. It's not that important to have the precise size for this underground box, because its purpose is only to be used to cut away these shelves that we do not need. So what's missing? We are clearly missing the walls, and we need a concept of how high the walls need to go, and after that it's just refinement. For instance, this bottom has rather sharp corners over here, and it doesn't need to have sharp corners. So we can touch up these, just give me the part design and make some nice smooth fillets. We need to activate that body in order to make that change. And there we go. And there is a limit to how large fillets we can make. We can make 5 millimeters, that works, and okay. That's just a little nicer. So now that we have our shelf arrays, we can join up the front shelves, the back shelves, and the bottom. We use the part tool union for those. And we shall cut away the underground from it. So we use the cut for that. The cut needs to be the opposite way around. How do we tell it this? Let's try just dragging. No. From the fusion I wish to cut the underground. That's the right way around. This is just about right, only we may as well refine it at this point. And that looks much neater. What's missing at this point is clearly the walls. There's one section of wall that is a little bit tricky, the front wall, but we'll start out just drawing the back walls, back and side walls, and we might also I just like those proportions better. We'll start with the side walls. So, part design again, not strictly necessary, but it works. Our view went funny because it zoomed in. I want to create a new sketch. This will be on the XY plane. In this sketch, I'm drawing a few rectangles. There will be a back wall. There will be some side walls. And these walls shall be of equal width. Of course, this side is hard to select now. Is that just because these are coincident? Yes, because that's the same point. Anyway, I want to set the vertical position of this. It needs to be equal to consequences.container depth. There you go. I want to set these two equal. I also want to set their width. I will set it to parameters dot wall thickness. There. I want to set this width to parameters length plus parameters dot margin. It's the right size now, but it's not properly aligned. So there is a problem. Oh, not a really big problem here. I just didn't see where that feature went. So these from this point to this point is also the wall thickness. There you go. Now we have a degree of freedom in horizontal placement here. The easy way to get rid of that is simply to make the whole thing symmetric. Now it says we have 2 degrees of freedom, and that's the length of these walls. And there are 2 approaches we could take here. We could make them overlap the front wall, or I could design the front wall including the part that would head down to meet the sides. I think I do want this to extend the entire way, so we take these 2 and we constrain it horizontal. This places them at the same level, and we take this and set its position here to negative parameters dot wall thickness. And close. At this point, I need to create one more variable, I believe, because we don't know the actual height of the entire container. And that may actually be a little bit tricky. I don't think I have a particular datum to refer to, because I think that this point may actually be, well, this point would be easy to calculate, but this point may be the more relevant. For now, I'll just enter what I want. So, I'll just enter the easier formula and we can refine it later. Let's set the container height. Let's make it equal to the first shelf start height plus parameters.shelves minus 1, because the first shelf is counted already. Or no, we include it. The shelves times the shelf height. That sounds a bit quirky, but it's close enough for the moment. So we copy this and we set it as the label or the alias. Both of those names are used in various places. And now we have this body, we have the sketch in here, and we can pad it. And it is confused. It's purple, so it should be active, and I believe it was confused by us being inside the spreadsheet rather than in the 3D view. The dimension now has some value we can use. We use the container height, and there we go. This is slightly higher than necessary, and we might refine that later, but for the moment, I'm okay with it. So it's beginning to take shape. There's also too much material in the back wall. I may want to remove some of that. So let us edit this a bit. In fact, let's first hide our other shapes because they are distracting, and edit this sketch. So we don't want this entire wall, we want a subsection of it. And I'll just... In fact, I think we could remove these completely, but I'll set these to construction geometry and draw a pair of new rectangles like this. From this point to somewhere on this line. And we set these to be equal, and we set their width to consequences dot shelf max width. We could add a bit of margin, but I'll leave it to later. There. And the pad has an error. I'm not sure why that is. This is a fully constrained sketch. So what's the problem with the pad? Error but must be executed. Mark to recompute. We'll start over. I want to perform a pad, and we see that it cannot pad this sketch now. I broke the sketch. The problem likely has something to do with the overlaps of things that exists in the sketch. Because this, well, it's an edge that maybe isn't actually needed. There is another edge there that I can't reach. So let's see here. We don't actually need that line, and we don't need this line, but we do need the line that specifies the width of this entire thing. So that the system has gone way under constraint because these are all distinct. So we have that box, we have that box, we have these two that now are missing their actual depth. We set these two to the same point. We set these to be equal. We set their height to the wall width. Actually, we can do that using this. And we want to set this to the container depth. As well as the distance from here to here, that point to that point, horizontally to the cell length plus the margin. Fully constrained. Update and close. Is this sketch now possible to pad or not? We can see that it looks a little bit odd. There is this intersection, and there is an edge inside of it. And curiously enough, that edge goes a different way there than there. Let's take a closer look inside the sketch, and we see that there is in fact that difference. So something has gone odd. We wanted this to be an outside wall. So let's delete that. The symmetry is still there. Sometimes it's just easier to start over, isn't it? Let's do that. I am going to just draw the simplest concept of the outline here. It's something like this. it goes vertically and to that point. There. These two are equal, and they happen to have a size that's the parameters wall thickness. That's a start. This has a length. It is consequences dot container depth plus because I want the front wall. Actually, let's discard that. Let's just set this consequences dot container depth. Okay, and we see that this flipped. That's the sort of thing that can cause real problems. So I'm going to set this length here to the container depth plus 2 times the wall thickness. And we see that it's going out further there because it is inside out over here. So now I set the height of this, and I set it to this, and it gets mad at me because it has flipped and it has trouble flipping back. So in order to fix this, I need to take this equality constraint, remove it, and flip it back manually, and then I can fix the height here. Property not found, wall thickness L. Well, why is it entering that? There. So this height, because it has no reference, has a significant sign. So we want it to be a negative to place the front wall outside of our container. Now I think we have the geometry correct, except for the length of this. We can set it to consequences shelf max width. There we go. And we have 1 degree of freedom, that is this. So we set the horizontal position of this to parameters.length plus parameters.margin over 2. And there we go. This is a complete wall. We could mirror this wall, and I think I might actually do that. In fact, I think we might do the entire setup using one mirroring if we want, but well, for the moment, let's start by padding this. I wanted to pad it with container height. We now have a wall. Can we mirror this feature? There is a red mark. I think this is not possible because there is nothing for this pad to build on. it would be possible if I were building this pad on the bottom. In fact, that might just be a good idea to do. So we have this pad, and I can transfer it. Move object to other body, and we move it to the bottom. It disappears. This body is now empty. And if I take a look at the bottom here, it now has one wall. It's also acting crazy, but that might be something else. I think the confusion, we have both this pad and this fillet there. Well, it's less crazy now. I suspect we had some sort of double display of this bottom here. But now we have this wall as one pad, and now that it is a feature onto the bottom, we can mirror it, and we do so using... we first must activate this body, then we can mirror it, and we now have walls on both sides. And so this mirroring mirrors the pad here, not the other operations. In effect, making it so that we have two instances of this wall. We can set it to refine. It doesn't really matter at this point. If we do so, it should remove these edges down here. But that shouldn't be necessary, because this fusion will have the... well, if not this fusion, then this cut should have the refine on. So those tiny details are disappearing here. Looking good. This would actually be a functional print. However, these walls are infinitely thin and really wouldn't work very well. So we want to add our front wall as well. This front wall, it pretty much requires that we have at least our second shelf, but if we don't have our second shelf, we only have one row of batteries, and we don't really need our organizer, do we? So let's start drawing such a front wall. We are still operating on the bottom without back curve, which has now been turned into the actual casing. This pad here is the bottom, and that pad is the one that is mid-plane, so it's going out either side here. This bottom is drawn in profile. But now we can draw some front walls here. So we create a new sketch. This time we're drawing it on this XZ plane. And we can draw a rough outline. It's going to be a quad of some sort. But this is not going to be horizontal. Here we go. That's a start. In fact, there's a slight difference here at the bottom as well. Or is there? No, we have the side walls, so this is fine. We're going to mirror it later on, so we can draw just one side, that's fine. We're going to set the horizontal difference here to parameters length plus parameters margin, And again, over 2, because we're only drawing one side here. Oh, turned inside out, doesn't really matter, we can draw other side. We're setting this to consequences, shelf max width. We're setting this point, and I'm a little uncertain about that one actually, so it can wait a little while. This should simply be the container height. And these are both variable, but I can tell that this angle should be the overhang angle. And this point, well, now that's a little tricky. This point should be at our this would be the lowest point of the second shelf, and this should be obviously match the overhang cut of that shelf. So it's currently a little bit too low, but I don't know off the top of my head what position this is. But we can calculate it, or we can sketch it out. So basically, if we start making some construction geometry, from this point there exists a slope. That slope is at the rolling angle. The rolling angle is actually not in consequences. We need it from one of our other sketches. It's in the shelf angle solver. Or do we have that angle? We do have the shelf angle in consequences. Good. So we set it to consequences shelf angle. And it goes back to the reference point for the shelf, which means this distance is equal to the container depth minus the shelf start depth. There we go. And this point we have a known height for. This point is the first shelf start height. And suddenly I'm way confused again. That does not seem right. Not at all. That's because this shouldn't be the first shelf, it should be the second shelf. So we add the shelf height. There we go. Close, and it's still wrong. So why is it wrong? Well, it's wrong because this is the point where this line goes. It's not the point where the cut rests. So this point is actually based on that curve up there. And it gets a little bit confusing. We can take an approach to use the external geometry and connect it, much like we did with the actual cutting plane. And come to think of it, the cutting plane might be one of the most important related parts. Do we have a way to access that? I'm not so sure. Do we have a way to recall how far in this is? Well, yes, we can calculate how far that is. Because we can still draw the same geometry if we want. This radius is equal to the diameter over 2 plus the margin, which is a bad name for it. It's much better to use the shelf start depth. These are tangent. Shelf contains conflicting constraints. That and that needs to be tangent, and it doesn't like that. Let us remove this constraint. Let us set let us add a line here that is vertical. These are tangent. These are tangent. This has some unspecified height. Let's just set it to 1 millimeter because that's not actually what we are looking for. Now we know how far in this should be. And we can remove the coincidence over here, which is a bit of a bummer. It's somewhere around here. Is it this one? Yes, indeed. Now that doesn't move. This does move, so that was not the constraint I wanted to remove, but we can fix that. I wanted to remove one of the constraints that matched that point. We have most things constrained, but we can move this curve. I actually didn't want it to work that way. I wanted this curve. Frankly, I want to remove this line. It's not helping anything. I want this to connect to this. And then I would like to I would like to move a point here. Specifically, let's remove that and see what happens. Let's remove that constraint. There. Now, this should be tangent. So now that's firmly fixed. And now we know how high that really should be. And this point, cancel that. This point should be horizontal with that point. That was a bit messy. If I had better reference data, I could probably have drawn this in an easier way. But this was what I had. Let's see if that's actually the correct placement. Sure doesn't look like it. And it is under constrained. What do we think is not constrained in this sketch? This distance, I'm not sure this distance is actually correct anyway. Okay, this is looking a bit messy. This should be on there, and it should be tangent. Contains redundant constraints. Number 18 should be removed. Then we remove it. So this is actually on that wall, but the exact position is not known at the moment. While this is known, and we need from here to here, this should be the container depth minus the shelf start depth. Fully constrained. Update, close. Still looks wrong to me. And the short of it is I really suck at this, don't I? I may need to mull that over. And this is the point we know, but we need, and we have drawn what should be this profile. This point should be where we match the height. And that is what we have matched the height of. But this should actually go all the way to the outside, shouldn't it? No, that's not a complete explanation, because the point is that this must match here, and for some reason it's higher. Is there something wrong with the placement? Position is 0. The attachment offset. Nope. I am confused, and I guess I may have to get back about this. I really want to solve this. So the easiest way is just to grab this geometry and map the face to be the same thing. But there is something wrong in my understanding of this geometry, and I really don't like that. I want to know that bottom point, and that bottom point, if I go into the shelf here, I should be able to see where that is. Well, that's hardly any help. Please make this sketch visible. It's not showing up. There. When looking at this geometry, we have this angle, we have this angle, we have this width, so we know that's 3 millimeters, but that shouldn't really matter. What we want to know for finding that overhang is actually the angle of this part, isn't it? Because our reference point is here, then it goes down here and down here. So we know how far out this point is, and we know that it needs to be cut at the overhang angle, but that is over here, it's not at the front. So that's probably our real problem. And if we want to fix it, there's actually something we can do inside this sketch. If I change this line to be a construction line, and I then add a few more lines to close this shape here, and back to this point, and this should be horizontal, and I set this to include the piece of the wall that's needed to hold this shelf. Close. All of a sudden there is a bit of wall as part of each and every shelf, and I therefore don't need to create the front wall in the same way. However, I suspect that the plane is now aligned to the wrong point. This datum plane is based on this pad. Let's remove a few other things from visibility. Yeah, the cut is now way too shallow. It's not going across the overhang angle as it should. And that's the risk with defining our plane by those 3 points, because those points changed when I redefined how this pad is actually built. And the pad is down there, so in order to see how it looks, I need to stop looking at the bottom. So we turn this fusion off, we turn the back shelves off. Why am I seeing the casing still? I need to remove the casing from view to see all this. I'm seeing the casing because this cut is visible. There. So this datum plane is now way too shallow because it's connecting to a point that's up here, and it shouldn't. And I'm seeing several parts here. I want to stop seeing the shelf part, and this is the basic pad. Now this is attached to 3 points, and I need to reset to change which points those are. So the first point is still here on the front. Let's make this plane invisible for the selection. The first point is here. Some of the points are coincident. The second point is here. And the third point is here. Now it's attached. It's using 2 points from the sketch and 1 point from the pad, which is a little bit confusing, but perfectly possible. So now it is at the correct angle again. And with that we should be able to see, there we go. We now have a bit of wall connected to each shelf. And since we have enough wall back here, we can just draw the simpler shape of the front wall above it. And so that datum plane isn't really very well defined, but we have corrected it for the moment. And our cut here doesn't seem to have cut away this, whatever this is. This looks like a piece of front wall that's gone underground. And this, which is a piece of shelving walls that extends outside. Our underground box is simply not as deep as it should be. So we change this. Let's just make it lots and lots and lots deeper and place it a little bit back in the y-axis. That's back far enough, I believe. But now that isn't long enough, so we just make it bigger. There, now the underground cut works, and our problem is back to creating the front wall again. So the front wall is supposed to be this sketch, which is now impossible to see. But the reason it's impossible to see is that we're seeing this cut, I think. Or there. We need to see the casing itself in order to see that sketch. So the casing needs to be our active object, so it's purple, and we need to edit this sketch. Now we know this is a little bit too high, but that doesn't really matter. It's going to cover from around here somewhere up to there. And we're going to pad it with the wall thickness. And we're seeing something funny here because we're currently seeing doubled up things. And we're going to mirror this feature here across YZ. And that happens to be the vertical sketch axis, so that's perfectly okay. And we can now hide this casing, and we have a front wall that goes all the way up. Better. And let's make this a little bit deeper, and I want another shelf here, and things are working. This is a proper parametric model. We don't have the low walls on the sides here, and this isn't any wider than the shelves actually require. And it's fairly thin as it builds up here, but that's because it really needs this opening. And this is a reasonable model. There's probably one more thing I would like to do to the model, but I've taken quite a lot of time already. The thing that I'm thinking of is again that when we look in the shelf size sketch, this cell is in fact resting in the wrong position. If I make some more construction cells here, I meant to make those construction geometry. So these guys shall be blue. And if this one touches this one, in fact, all of these need to be the same size for starters. This touches this, and this touches this, and this touches this back wall, and this touches this. Now this is a bit further out than this one is. So this one shouldn't be on this straight edge, it should be on this curve. And the exact position may be a little bit tricky to calculate, but we can do that. Well, for starters, we're going to need to detach this, aren't we? This length, I want to edit it. I want to remove that last cell from that calculation, because I want to make this be that last cell. And then I want this to, while it touches that, be at the same horizontal distance as this is. So if I draw a support line from here, it's horizontal and it touches, it reaches this point. Then I want to have, actually I want to have yet another cell. I want to have the cell that is behind here. Like all the others, same size. But this cell so let's remove that constraint. So we can take this and we make these touch and these coincide. This support line should match the support line for, let's see, not this cell, but the cell behind it. So we draw yet another cell. Here, set these to equal size. Set this to touch the shelf. And touch this cell. And add a support line from this to here, horizontal. Choose on it for a while. And I want these two to be of equal length over constrained sketch. That would be because this is the wrong constraint. And this cell is in fact a bit bad because it should not have this constraint. 1 degree of freedom. I think that I removed the wrong constraint first. What we learned is that this cell isn't actually on this shelf, so that is the constraint we want to remove. Here. There you go. Fully constrained sketch. This looks a little bit messy, and that is because this well, now something is probably confused here, because this cell doesn't look like it's in a physically possible position. And I think this is why. It's not touching the correct edge. It should be touching this edge. Because that's the cell that is currently on the curve. We can see here that this cell has then been pushed over. It's resting on this cell instead of resting on the shelf. And this is the second cell in the shelf. So this works for 4 cells. That's nice. What about for 3 cells? Update. Choose on it for a while. Doesn't in fact look like it understood that. There we go. We have a result. There is a solution for 3 cells. Now, I don't actually want to have 3 cells per shelf, but it is a possibility. Let's set it to 5 for now. And choose on that. Actually, no, it doesn't. If we just close this, then it will solve it. So this shelf size sketch is now calculating using a quite different formula. This represents the second to last cell in the shelf. This represents the second to first in the shelf. This is the last cell of that shelf, and this is the first cell of the next shelf. So this it's touching the back wall, just like this is, well, not touching the front wall because the front wall doesn't exist for this shelf. But that should actually give us a correct count of cells per shelf. And with that, we also have one more value we can calculate. Because the top of this cell should be the top of our, well, it's the top shelf height when related to the last point here, over there. So we're going to place a reference constraint here, and we want to use a point. That's a coincident constraint, not a point. We add this point. This point should be vertical with this. So that's the highest point on the last cell for this shelf. This point to this point is a reference height I want. I'm going to name this top shelf height. Close. Now I can add that here. Shelf size sketch, constraints, top shelf height. And alias, and now I can adjust the container height. To remove that and add that. Now it is ever so slightly lower, but it's just enough height to hold the last cell. And that, I think, is a fairly refined shape. Of course, those low walls on the sides here might be helpful so that you don't easily knock a cell out either way. But I don't think that's a great problem. Also, we have a parameter for how many cells are actually accessible out here. And I think this is a pretty good shape. So I'm going to post this online, and maybe it will be of use for someone. I will probably try printing it and see if it actually works as well. And this, well, concludes my first attempt at redrawing this shelf shape. It's not a perfect match for the original. If we compare Thingiverse here, we see that there are walls here. The wall is lower for the front. This is not quite as wide, but on the other hand we have rounded corners here. His overhang angle is a bit steeper than mine. Furthermore, we can see that he has added more back wall than the overhang angle, and this cut continues all the way through the front wall. I did not do that. My front wall is actually straightforward, so I don't have this sharp corner. So this spacing is much smaller on his, and that means he should have more stability in the walls. But I'm not sure that's actually going to be a big problem unless you make it really, really tall. And even if you do, the cells resting on the shelves should be pushing it together rather than apart. But that depends on the angle of the shelves. We could have made the shelves into a sort of rail shape to ensure that, so that there would be some momentum pulling the walls inward. But I think it's going to be rigid enough for most scenarios. That, well, much more refinement is possible, but at the moment at least I have a few parameters that can be set, and I can make a battery holder about as large as I want it. We can probably now just move these 3 labels, transfer them to that column, and we get a AAA battery holder. And here it says capacity 17, so we could also alter the code to calculate from the required capacity, or with a lot more effort we could calculate it from the required size of the container. But we have a start, and I'll be sharing this design. Thanks for now.